Welcome everyone to our online NPTEL course Environmental Chemistry and Microbiology. This course will be taught by Professor Sudha Goel and myself, Professor Anjali Pal. We are from Civil Engineering Department, IIT Kharagpur. We have divided this course into two parts. The first part, environmental chemistry, will be covered by me, and the second part, environmental microbiology, will be taught by Professor Sudha Goel. This is my module 6 and lecture number 26. In my previous modules, I have covered the acids, bases and salts in the first module. In the second module, I have discussed about the chemical equilibrium. In the third module, I discussed about the chemical kinetics. In the fourth module, I covered the catalysts. In the fifth module, I discussed about the chlorine chemistry and nitrogen chemistry, and this is my sixth module and lecture number 26, where I will teach about the radioactivity or nuclear chemistry. This is part A. This chapter, actually radioactivity or nuclear chemistry, is very interesting chapter, and you know, for this type of means development, there are many Nobel Prize. You will see that atomic structure and radioactivity, they got many Nobel Prize, and very interesting. You will find this topic very interesting. At least for me, it is very interesting topic. Now, the lecture content, you know, the lecture in this lecture, I will discuss about the basic thing about the radioactivity. Then I will tell the history, that means how the radioactivity is discovered. Then difference between the chemical reaction and nuclear reaction, because this chapter is for nuclear reaction. I already discussed many things about chemical reaction, but now I am coming to nuclear reaction. So, I will tell you what is the difference between these two. Then stability of nucleus, what makes a nuclear very stable or unstable, and then properties of alpha, beta and gamma rays I will discuss. Now, what is radioactivity? You know that some nuclei undergo very spontaneous disintegration, okay, and disintegration is accompanied by emission of particles, say particles or rays. Say for example, alpha particle, beta particle, you will see when I will discuss in details about the properties of these particles. Now, who will be unstable, which type of nuclei will be unstable, that depends on the atomic number, you know, and the neutron proton ratio. Now, mostly we have seen that heavy atomic number greater than 83 makes a nuclei very unstable and they become radioactive. Some of these elements, they occur in nature and some of them can be formed artificially by man, that means they are man made. Now, the nuclei of these radioactive elements are unstable. Radioactivity means they always give up, or they always radiate some particles or some rays, that means they are unstable. Now, this means that they cannot remain as they are, means so how they are, they cannot stay like that, they always give up some particles or rays, and in doing so they are converted into another atom. And finally, at the end, although it may take long time, but at the end they are transformed into some isotope of lead. This type of decay, this type of disintegration is called radioactivity, okay, and they are called radioactive disintegration. Now, discovery of radioactivity. You all have heard the name Henri Becquerel, French scientist. In 1896, you can see that he discovered this radioactivity. And how? You know that in their family, in his father and his grandfather, they are all scientists. It is a scientist family. And what they used to do, they used to take some actually uranyl sulfate. It is a uranium compound. It has some fluorescence, but to show the fluorescence, you know, it has to be exposed first with some light, sunlight, say for example. So, what they used to do, they used to irradiate it with the, it was kept in a bottle, the compound was kept in a bottle, it is an uranium compound, and then they exposed it with sunlight, and they used to show the fluorescence to the village people. This they used to do. And also Becquerel, you know, 1 year back the X-rays were discovered, and then he used to do some experiment with this type of compound, fluorescent compound, and he used to see whether X-rays are coming out or not. So, what happened, there are few days there was no sun, and it could not be exposed with the light, and it was kept on a tabletop, and in the drawer which is below, means below the tabletop, there was some photographic plates kept. Okay. So, there are some photographic plates, new photographic plates, but these new photographic plates were wrapped in black paper. Okay. So, that why they have kept, because if it is exposed to any type of light, then it cannot be used anymore. That is why it is kept in a wrapped in a piece of black paper. And so, it was in the drawer, and on the top of the table he kept that bottle. Okay. So, and there was no sun for the few days, for the last few days. So, it could not be exposed. And then what happened, when he has seen that the photographic plate, when he took out the photographic plate, he observed that it is already exposed. So, but he was surprised to see that. Why? Because the bottle in which the uranyl sulfate, potassium uranyl sulfate was kept, that was on the tabletop, and the photographic plate was inside the drawer, that too wrapped with a black paper. Then how come some light can come inside, and how can it can expose the photographic plate? So, he was very surprised, and then what he did, he again did the same experiment, and he wrapped the photographic plates with, even with aluminum and copper sheets, but then also it was exposed. Then some idea came to his mind that it must be some type of light or some type of rays that is coming from the uranyl sulfate, okay, and that is exposing the photographic plate. He repeated the experiment many times, but then he could not understand why it is happening. That time radioactivity was not known. So, he could not understand why it is happening. Now, then the similar experiment, then he published it in somewhere, and then another scientist, you all heard the name, that Madame Curie, what she was doing, she was just about to start her research, and he was trying to find out some good topic for her research. Then that article, she has noticed that article, and then he was thinking to start his research in a very new and very challenging topic. So, when he saw this thing, then he was very much interested to do research in that area. Then this practical problem was taken up by Madame Curie and you know, in France, and then her husband Pierre Curie. So, this topic, this research field was continued by them, and lot of research was done by Madame Curie and Pierre Curie, and then it was realized that it is not the property of potassium uranyl sulphate, but it is the property of uranium itself. That means, any compound which contains uranium may show this type of effect, and he did with they did with pitch blende, some uranium ore. And then the phenomena why it is happening was to some extent realized that it is some atomic phenomena, and some atoms are radiating something which is spontaneous, means nothing can affect this property, inhibit this property. Okay. And then another thing they realized that it is the property of uranium itself. Then they were trying to find out, means extract some amount of uranium from the pitch blende, that is the ore, and tons and tons of uranium they were using to isolate little amount of uranium. But what they realized that pitch blende it is showing much more radioactivity than the uranium itself. So, what is the cause for this? Then they found two more elements from there. What is that? That is the polonium and radium. So, why the name polonium came? Because Madame Curie was from Poland. So, on her means motherland, on the name of her motherland, the new element which is also very radioactive element, and another element radium, these two elements were isolated, and the name of polonium is given by Madame Curie according to her motherland. And the term radioactivity was also coined by Madame Curie. Okay. So, she first gave the name that it is radioactivity. Why radioactivity? Because radiations are coming out from those elements, that is why radioactivity. And as I said that this property is independent of any external condition. If you increase the temperature, if you increase the pressure, or if you give some light, it does not matter, means it is automatically coming out spontaneously. For this type of phenomena, means first time observed by Becquerel and Madame Curie and Pierre Curie, the Nobel Prize in Physics was given in 1903 to Becquerel, Marie Curie and Pierre Curie for the discovery of radioactivity. And you can see that second Nobel Prize on this particular topic was second time Madame Curie got the Nobel Prize in Chemistry in 1911. Why? For the discovery of radium and polonium. Okay. So, two times she got the Nobel Prize, two times, once jointly and another single. Now, this is the history of discovery, and then why some nucleus is unstable, why some nucleus are stable and some nucleus are unstable. This was explained by proton neutron concept. What is this? The number of protons and neutrons in the nuclei of the atoms of low atomic weight, means when the atomic weight is less, then the neutron and proton, the numbers of protons and neutrons are almost equal, okay, almost equal, but the relative number of neutrons becomes increasingly greater for elements of higher atomic weight. And for example, the C is 12. Okay. So, carbon is an example. The 12 is the atomic mass and 6 is the atomic number. You all know that what is atomic mass and what is the atomic number. Then 6 so why it is 12 the atomic mass, because it contains 6 protons and 6 neutrons. Okay. So, the proton neutron, if you see that the ratio n is to p is 1. Okay. So, it is a very stable nucleus. Carbon 12 is very stable nucleus. But if you see the uranium 238, this is the atomic mass number 238, then it contains 92 protons and 146 neutrons. That means, neutron is to proton, the ratio is much greater than 1. This makes the uranium nucleus unstable. That means, neutron proton ratio when it is 1 or close to 1, it is stable, but as it goes on increasing, then it becomes gradually unstable. Okay. You know the nuclear structure, you know the atomic structure. Okay. According to Bohr model, we all know that in an atom, the nucleus is at the center occupying a very small space, and rest part which is much greater than the nucleus, that space the electrons are orbiting. Okay. In the nucleus there is there are protons and there are neutrons. Okay. And each proton has unit charge and unit positive charge and unit mass, 1 unit mass, and neutron has no charge, but it has unit mass. So, that we all know from our school days. And electrons has no mass, but electrons has unit negative charge. Okay. So, how will you write the any element when I want to show the atomic mass and atomic number? Atomic number is the number of protons. How I can write? I can write both in this side also. In many books you will see that in the top part the atomic mass is written, and then in the bottom part atomic number is written. So, 12 and 6 in this case both are written in this side, one in the top, another is the bottom. But in some books you will see that it is written in this fashion also. Same is for uranium 238, it is the atomic mass and then atomic number. Okay. Atomic number usually is represented by Z, and atomic mass number is usually represented by A. Now, then A minus Z is the number of neutron. Okay, because the mass is coming from the proton and neutron, each of having unit mass. Now, what is happening? How? Why? The nuclear, you know, you can think that in the nucleus there are many protons which are of unit positive charge, just now I told. So, they should repel each other, there must be some repulsive force acting, and so how they should that means the nucleus should be broken. Okay. But why, what makes them stable? Actually, the it is the short range force. Short range force means it is within the nucleons there is some force, and that force is much higher, and it is overcoming the repulsive force. Okay. And the relation between the neutron and proton, you can see that neutron, if it takes up one positron, what is positron? Positron, it is the positive electron. So, that can give you have seen this type of this in chemical equilibrium also. So, these are dynamic equilibrium. So, neutron after taking one positron can form proton, and again proton after taking electron it can form neutron, and this is another type they have shown, that neutron may give the proton with the electron and neutrino. Okay. Similarly, proton can give one neutron and then positron, and then anti-neutrino. Okay. This type of equilibrium may exist and making them stable. Another theory is given by Yukawa, that is the meson theory in 1935. Pi is the meson, you know. So, proton can give neutron and positive meson. Similarly, neutron can give negative meson and proton. So, these type of concepts are there to make the nucleus stable. Now, as is shown in the figure, you can see that here in the x axis it is the number of protons p and here number of neutrons. Up to 20 you can see that number of protons and number of neutrons are same, and then as you go on increasing the number of protons, you can see this is the line for 1:1 neutron proton plot. Okay. Now, as you go on increasing the number of protons, you can see it is the line that it is deviating from this line. Okay. And actually after 83 Z83 all the nuclei are very unstable. Okay. And you can see that 83 after with Z up to 83 they are more or less stable, but beyond this point the n/t ratio increases more and more, leading to nuclear instability. All elements having Z above 83 are unstable and shows radioactivity. So, this is the thing, here 83 is almost here. So, you can see it is much deviated from this line and they are radioactive. Okay. Now, the properties you can see the particles that is coming out, that are coming out from a radioactive element. Okay. What is this? This is the figure, you know, this is a lead block made of lead. Okay. And then here there is a small hole. Okay. And here some radioactive element is kept. So, and then some radiations are coming out, some particles are coming out from, as I explained in the previous slide, that radioactive elements they are disintegrated with the emanation of the some particles. Okay. And then when some magnetic field or electric field is kept, magnetic field in the if this is the paper, plane of the paper, it is the perpendicular to the plane of the paper, then you can see that it is these particles are deviated from its path, it is deflected, actually deflected. So, what you see, these are the alpha particles and these are the beta particles and this is a gamma particle. Gamma particle is not gamma rays, it is called gamma rays, it is not deflected. Okay, it just goes away like this, but alpha particles are deflected towards the negative end and then and the beta particles are deflected towards the positive end. Okay. Now, you can see here that alpha particles are deflected less compared to the beta particles, because what is alpha particles, we will see that they are having more mass compared to beta. Okay, mass and charge. What is alpha particles, I will tell. So, alpha particles are identical with helium nuclei. Okay, they are the helium nuclei. What is there in the helium nuclei? Helium nuclei, I can write helium 4 and 2. Okay. So, atomic mass is 4 and atomic number is 2. So, there are in the nucleus there are 2 neutrons and 2 protons. Okay. And there are 2 electrons. So, it is the nuclei of helium atom. Okay. And what is beta particle? Beta particle is nothing but the electrons. Okay. So, there are different properties they can show. What are the different properties? You can see that the penetrating power of the alpha particles are weak. How much is that? 0.01 millimeter of aluminum foil. So, you can stop it, you can stop alpha particles by using this aluminum foil having the thickness 0.01 millimeter. Okay. And ionizing power is very high, ionizing power is very high, and the track, how it goes by straight tracks, straight line it goes. And speed is as it is shown here, it is almost 1/10 of the speed of light. Okay. But beta particles, they are very similar to electrons, and penetrating power is much higher than the alpha particle. It is 0.1 millimeter of aluminum foil. You can see in some books it is written 5 millimeter also. So, it varies from book to book, and also the material also, somewhere it is written aluminum, somewhere it is written something else also. Now, ionizing power much weaker than the alpha rays. Okay. Cloud chamber track, you can see the track in, there are many instruments by which you can see how is their track. Okay. So, in the cloud chamber, this is one method is cloud chamber, you can see that they are showing not the straight tracks, they show thin irregular tracks, the beta particles. And speed you can see it is approaching towards the velocity of light, but it is not the same, but it is much higher than this one. Now, what is gamma particles, gamma rays or gamma particles? These are short electromagnetic waves, and the penetrating power is very high, 8 centimeter of lead. It can pass through thick sheet of lead, 8 centimeter of lead it can pass through. Ionizing power, ionized air, cloud chamber, short crook tracks. Okay. And then speed you see that light. So, these are the properties of the alpha particles, beta particles and gamma particles. The radiations from a radioactive element, okay, who has observed many of the properties, they are studied by Becquerel, Rutherford and Villard, and Rutherford got the Nobel Prize for such type of studies. The properties of the rays that is coming out, or particles that is coming out from the radioactive element. So, 1908 Nobel Prize was given to Rutherford. Now, you can ask me that as you see that radioactive elements, they produce beta particles. So, where from beta particles are coming? Is it the orbital electrons that it is giving off these beta particles, because beta particles are nothing but electrons. Actually not, it is not the orbital electron, it is coming out from the nucleus due to some conversion, is not it? So, so it is fallacy. Okay. Many school level questions it is given that what is the source of these beta particles, where from it is coming. Now, nuclear reactions versus chemical reaction. You have already learnt chemical reactions, many things about the chemical reactions, and here now you are studying the nuclear reaction. So, what is the difference? You know, nuclear reactions are irreversible reactions. Once it is means alpha particles is emanated, it cannot it is coming out, it cannot go back. But in chemical reactions we have seen, say for example, nitrogen and hydrogen is are reacting to form the ammonia. So, ammonia is also going to be converted to nitrogen and hydrogen, that you have seen. So, it is when it is means equilibrium, the both processes are taking place, but here it is not like that. Okay. But new elements are formed in a nuclear reaction. When something is coming out like alpha rays, beta rays, then the nucleus of one element is converted to the nucleus of another element. That means the atomic number is changing. Okay. So, it is nucleus is changing. Okay. So, element is changing. Okay. But in case of chemical reaction, you know, nitrogen, say for example in ammonia synthesis, nitrogen is remaining the same, hydrogen is remaining the same, only it is combining with one another to form another compound. So, this is the difference. Now, radioactivity is an atomic property, as just now I told during the discovery Madame Curie, she observed that it may be some uranium, any uranium compound that will show the radioactivity. It may be pitch blende, it may be uranyl sulphate, potassium uranyl sulphate, it may be some other compounds also. Okay. So, it is the atomic property, but in case of, that means it is the characteristic of an atom in which the change is occurring, but in case of chemical reaction, it is not the atomic property, nitrogen is staying the same, hydrogen is staying the same, only thing they are combining with one another. Okay. Now, a nuclear reaction occurs spontaneously, no external factors such as pressure, temperature, catalyst, light has any influence on it. Okay. On the radioactive disintegration, but we have seen in the chemical reaction, you know, depending on the pressure, temperature, we can change the speed, okay, of the reaction. Okay. Here it is not possible, okay. It is automatic, it is spontaneous. And then energy change that is involved in nuclear reaction is much higher compared to the chemical reaction, okay, and it is maybe 10,000 times higher compared to the, or even more compared to the chemical change or chemical reaction. So, these are the differences between the nuclear reaction and the chemical reaction. Now, to understand this radioactivity radioactivity topic, we must know a few things. Say for example, isotope. What is an isotope? Atoms of given element having the same atomic number, but different atomic mass are called isotopes. Okay? And nuclei of such atoms contain the same number of protons, but different number of neutrons. It is obvious, because if the proton number is same, but atomic number is that means atomic number is same, but atomic mass are different, then the difference is nothing but the number of neutrons. Okay. So, number of neutron must be changed, must differ. And the examples of this type of isotopes, the base most simple is the hydrogen. You know, hydrogen, you know that it has the atomic number 1. Okay. So, whatever isotopes of hydrogen may be, it should have the same atomic number. So, hydrogen, deuterium and tritium, you see the proton number is same, 1 1 1. But the proton number means atomic number is same, but the atomic mass, that is different. Okay. So, here in hydrogen it is 1, in deuterium it is 2, in tritium it is 3. Okay. So, they are the isotopes. Now, isotopes of magnesium, you see here the atomic number all are same. So, but the atomic mass is changing. Atomic mass changing means the number of neutron is changing. So, here 22, here 25, here 26, that is the atomic mass. So, these are called atomic means these are called isotopes. Okay. Now, isobars, nuclei having same mass number is same, but different proton number are called isobars. They have different chemical properties. These isotopes have similar properties, because property is decided by the atomic number. Okay. So, these are having the only thing is the mass, okay, changing, and here isobars, you see the mass number is same, but atomic number, that is the proton number, is changing. Okay. That means they are different elements. Atomic number changing means they are different elements. Okay. So, for example, here barium and lanthanum, you see here the mass number is the same 138, but here the atomic number is changing 56 and 57. So, they are different elements obviously. Okay. And isotones are nuclei with same number of neutrons. but different mass number are called isotones. So, they have the same number of neutrons, okay, same number of neutrons, that means difference between the atomic mass and atomic number. In this case it is silicon, phosphorus and sulfur. Here if you see the difference 30 minus 14, 31 minus 15 and 32 minus 16. So, they are same. Okay. So, 30 minus 14 is same as 31 minus 15 is same as 32 minus 16. So, the difference is nothing but the number of neutrons. So, they are having same number of neutrons, but different mass numbers, and obviously these elements are different. Okay. Okay. So, now what do you mean by nuclide? Nuclide in an atom, you may in the books when you go through this chapter you will see they are writing nuclides. Okay. So, what is nuclide? In an atom the number Z is the atomic charge or atomic number and N is the number of neutrons that I just told, and A is Z plus N. Okay. A is the atomic mass number. Okay. So, the parameters A and Z completely define a particular atomic species. Okay. So, if you tell about for a particular element what is how much is A and how much is Z, then you already define a atomic species, and this is the nuclide. Okay. What is radioisotope? An isotope which shows that radioactivity is called radioisotope. So, isotope may be not radioactive, that is possible, but radioisotope means they are isotopes, but they are radioactive. Okay. So, for this topic everywhere in under module 6 you see the same references I have mentioned. All three are very good books, although they are much elaborative. In this time period everything cannot be discussed, but most important points I will discuss, but in these books it is described in much elaborative way. Many things are there very elaborately, and if you want to study this very interesting topic, so if you want to read more, you may consult these three books. Each one is very good. Now, as a conclusion I can tell that in this lecture I have told about the discovery of radioactivity, properties of radiation that is coming out from the radioactive substances, and why some nucleus is unstable, those things are explained, and what is the difference between a chemical reaction and a nuclear reaction is elaborated. Thank you so much.